Hello everyone, welcome back. In this presentation, we will focus on prime factorization. In this presentation, I am gonna apply Fermat's factoring method. Let's dive into the outcomes first. Upon the completion of this session, the learner will be able to, outcome number 1, we will understand how to factor a given number using Fermat's factoring method. And outcome number 2, we will know about the pros and cons of this method. Let's dive into the topic of the day, the factoring method. As I already mentioned, we are going to focus on Fermat's algorithm. Why do we need this algorithm? Say you are given with a number n, and if you want to find the two prime factors of that number, then we need some technique to find it out. Say for example, you have taken two prime numbers 2 and 5. The product of these two prime numbers is 10. See, if you are given 10, you need to find out what are the two prime factors of 10, 2 and 5 in this example. So we want to find the values 2 and 5 given 10. That's what the topic of the day, Fermat's factoring method. So the main idea is to factor n, where n is the product of two prime numbers x and y. This can also be p into q. In this example, I have taken it as x and y. Say you are given with the number n, where that n is already a product of two prime numbers x and y, but you don't know what is the value of x and what is the value of y. You are given with the number n. And if you are required to find what are the two prime numbers that gave this number n, then we can go for this algorithm. But the drawback with this Fermat's factoring method is that this algorithm works well when x and y are close. Say for example, you have prime numbers 5 and 7. 5 multiplied by 7, we get 35. If you are given with the number 35, you can use this Fermat's algorithm to find out the numbers 5 and 7. Since 5 and 7 are close to each other. Anyway, this is a simple algorithm, so let me explain this now. So how we are gonna do this? Please make a note of this formula. N is equal to x square minus y square. We know very well that we are going to find the two prime numbers of this number n, because this n is a product of these two prime numbers x and y. So I am going to use the notation n is equal to x square minus y square. I'm not going to derive this how it has come, because this is not a mathematical lecture, rather this is a cryptography class, so I'm going to focus on the application areas. So I am directly taking n is equal to x square minus y square. Say if you want to find the value of x, I am just rewriting this equation as x square is equal to n plus y square. So this first equation is rewritten like this. Now as I mentioned, I am gonna find x. So x is equal to square root of n plus y square. Say we are going to use two formulas. One is this and the other one is this. So we are going to solve this problem by applying the value for y from 1, then 2, then 3 till we get a perfect integer this side. If a perfect integer is obtained for a certain value of y, then we are going to use this formula. I know things will be a little bit difficult at this stage. No worries. When we see an example, it will be clear for you. So before stepping into example number 1, please make a note of this formula. X is equal to square root of n plus y square for getting the perfect integer. Once we get a perfect integer, to generate the two prime numbers x and y, we are going to use this formula, which is equal to n is equal to x square minus y square. Why waiting? Let's dive into example number 1. The question is, factor n is equal to 187. So please note here, you are given with the number n. Now we are going to find the two prime numbers where the product of these two prime numbers is 187. So we are going to find those two prime numbers. Let's solve this now. What formula we are going to take? I already told you in the last slide that we are going to take x is equal to square root of n plus y square. We know the given data for n is 187. I'm just going to use this value 187 here. So we get x is equal to square root of 187 plus y square. As already mentioned, we are going to start with the y value 1. So let's start with y value 1. So we get x is equal to square root of 187 plus 1 square, which is equal to square root of 188. Square root of 188 is not an integer. So when we take the value of y as 1, we are not getting a perfect integer, because y equal to 1 has not produced an integer. Let's try with 2. So when we apply 2, we get x is equal to square root of 187 plus 2 square, which gives square root of 191. This is also not a perfect integer. Let's try 3. When we try 3, x is equal to square root of 187 plus 3 square, which is equal to square root of 196, which is equal to 14, which is a perfect integer. So we are going to stop at this stage. So we get x is equal to 14 and y is equal to 3. So we got two values, right? X is equal to 14 and y is equal to 3. Is this the final value? No, this is not the final result. Please note, this value of x and y are intermediate result. So this is not the final result. Yet we need to apply one more formula. Before that, let's see what values we got. X is equal to 14 and y is equal to 3. This is not the final result. Just recollect one more formula. What is that? N is equal to x square minus y square. How can we rewrite this x square minus y square? It is x plus y into x minus y, right? So we know what is the value of x here and what is the value of y here. So just place this value in this equation. We get n is equal to 14 plus 3 into 14 minus 3. So 14 plus 3 is 17. 14 minus 3 is 11. These are the two prime numbers where the product of these two prime numbers is 187. So 187 is equal to 17 into 11, where the prime factors are 17 and 11. So the answer for this question, factor n is equal to 187, is 17 and 11. Let's see one more example. Let's see example number 2. Factor n is equal to 3233. Let's solve this now. We know the formula is x is equal to square root of n plus y square. We will apply the value of n here in this equation. We get x is equal to square root of 3233 plus y square. So we will start applying with the value 1. When you apply the value 1 to y, we don't get an integer. When we apply the value 2, you won't get an integer. When you apply the value 3, still you won't get an integer. When you apply the value 4, you get square root of 3249, which is equal to 57. So from this, the value of x is 57 and the value of y is 4. This is not the final result. Please make a note of this. We have one more formula to substitute. Before that, let's write what is x and y. X is equal to 57 and y is equal to 4, which is this. So let's recall the formula. The formula is n is equal to x square minus y square. So this can be written as n is equal to x plus y into x minus y. We know what's the value of x and y now, right? So we will substitute the value of x and y in this equation. We get n is equal to 57 plus 4 into 57 minus 4, which gives 61 and 53. 3233 is the product of two prime numbers 61 and 53. So the answer for this question is 61 and 53. So before we sign out, let's see the homework question. The question is factor n is equal to 3009. I request you to solve this problem using this Fermat's factoring method and post your answers in the comment section. This algorithm works fine when the value of x and y are close. And that's it, guys. I hope now you understood how to factor a given number using Fermat's factoring method, and we know the pros and cons of this method. I hope this session is informative and thank you for watching.